Hello, my name is Philip Adelabo, and I want to explain how I wrote the codes in network programming that allow a client to communicate with a server machine. Now, the server is a program that will be running continuously in the background as a demo, while the clients can come in and go off depending on how you want to interact with the server. Now the client will send information to the server searching for a file. Okay, if the file exists in the server should be able to tell if it exists, and if the file is in the server should send to the client a URL link or path to the file into the server, so the client can from there try to download the file. But before I go into explain the code, I want to show you exactly how the image look like. Now, the red section here is the server, while the one at the right hand side here is a client machine. Now, the program of the server run in such a way that it has to listening to a certain port. These port are the one circled here. We have different port numbers, so every port has a designated number to uniquely identify the port. So there must be a host name, that's the address of the server, and a particular port through which other machine can try to connect to. Now the server that has several ports here must have each port with a particular program attached to it listening. So it is now left for the client to actually know what kind of program is run at a particular port. So here we must agree in the port number. We gave the port number here in the program. I will explain to you very much better. Now let's come here and see exactly what happens. Now here I have two command environments. My command environment here, if I say directory, it's going to show me the file at that particular directory. Now you see that we have server here, we also have a client here. So there are two different applications. So I'm going to first clear the screen and try to run the server. Now server. Now when I do that, you will discover that my server is currently listening. Server listening on desktop. This desktop is the system host name, or a kind of encrypted or encoded, let's say, IP address. Now the port at which is listening is 5643. Is 5643, which actually can be seen here in the source code. I'm still coming back later here to show you exactly what I mean and how they are being configured. Now if you come down here, you see port number here 5643. This is a port number at which the server is trying to listen on. Now let's come to the command environment here and try to run the client. Now run the client is the same thing as run the server. I write Python, then clients.py. So when I do that, you discover that here the server just said new connections accepted from 127.0.0.21. Now this is a kind of a channel through which the server would not try to create, so that the server and the client can at that point on exchange information. A bilateral kind of information will be going on between them, while it's still listening to this same port 5643 for other particular program to connect into. Now if you come down here, you see that the client say client not connected. Now enter the file to search. This client is just here to send a file to a file name, let's say the file name, to the server, so that the server can help search the file name. Let's assume that maybe I have a file called document. I'm not sure, but I'm going to look there if something of such exists. If I say document.py, then I send it to the server. The server will go through everything, search its own directory to see if it finds such thing, but it couldn't find a particular file called .py. It gives the client back the message here. Now before we try to understand how exactly the file is structured, now if I come to my document down here, I created a file called doc here. This doc here is a file that I shared. I must first share it as a network file. Then that is achieved by doing like this. Click on it, go to properties. Now if you look very well here, you see sharing. Now this is the share folder. I actually have to streamline this small folder here, because if I have to put my entire C drive, it will take some time for the server to search through all the folder to find a particular file. So I have to limit the search to the particular directory only called doc. So this particular part is a network part through which I have to make sure that the server link it up and search for file from there. Then, but because I've already shared it, I don't have to share it again anymore here. Now let's come back again here again one more time. Now I want to see a kind of file that exists in the share folder and search through it to see exactly if our program work as expected. Now let's go back to the doc. If I open, let's say, books, now I want to take this particular one called a short one that's not too long. Okay, ML challenge. Let's see, ML challenge dot PDF or PDF file. It's a PDF file. If you search for it, now that was too fast. It said okay. It said he found it. Actually, he found the file, and it sent to us exactly the link, the path through which we can find it out. Now let's go back again here and see exactly what happened. Where is this is it. Now let me explain to you the code exactly how it works. Now starting from here, I have to import a socket. The socket here is a module within the Python ecosystem. It is responsible for creating the network connections. So, but before then, I have to call upon it an object, a method, which this is a method called socket2 that takes two arguments. The first one is socket.afinet, that is the address family of IP version 4, while the socket stream is a TCP IP connection stream. Now here I have to just make sure I get the host name, that is the machine at which the program is running, that's the server, the host name. Do you remember that here we have the name of my system given as this is a port. Now this one will now bind the server to this host and the ports. It will bind the program, the server, to this host and the port. The host is my computer name here, or the local IP address called 127.0.0.1, while the port is a 5643 through which a client can connect to. Now when I say listening here, I mean to say that my computer, or the program rather, can accept 4 different connections from different clients at the same time. So here also too, there's a particular try and error to make sure that if any error happen within this particular try block, it should be able to be trapped here. If any error is being triggered within this try block here, the except block will catch the error and print out on shutting system, server shutting down. Now here, final here means that after all is done up down here, my connection can close. But before then, let's come again back here. Now this while loop, that's a while loop called an outer loop. Another while loop is an inner loop or inner loop. The outer loop is responsible for the continuous listening on the ports, attempted to try to accept a connection from any client. So my while loop will continuously listen and accept a connection from any client come in, while this particular line here is a print line that will print to the console this information: new connection accepted from this address. Remember again that this particular accept connection will return the address of the incoming client and also an handle of the connection where they can both be communicating from there on. So the inner while loop is responsible for both receiving and sending information to from the server to the client. So it will receive a byte of 1024 in size data. So when that one is received, it will check to see if the data being sent from the client is a keyword stop, exit, in, or finish. These keywords can be sent from the client to determine if the client is done searching for a file. If it's not done, then you will send the file name through which the server should search for in its own directories. So if the data is not any of this information here, then we can continue here with this parent particular format here. All right, now that is data has been received from the clients. This is the data by name as a file. Of course, this message will be sent to the client, say okay, we are sending this message to tell you that the server is searching for the file. So when that one is done, while we're indicating to the client that we're searching, this data is sent to a particular file named find file. It's an utility that is created. This file is from this particular utility here. The utility is just there to help and assist the program to run effectively. Now, where this find file, a find file is used to search for file, and that is a particular network address or network file through which the file is going to search in recursively. Of course, the extension will be extracted from the file being seen, and also we walk through the OS to work. We traverse the entire directory within this dock here recursively, and when that one is done, each time we traverse a particular directory, every single file there will be here search for and compare to see if the name matches. Now, the name matches, then it is found, they will not put the file into this directory called this list, because you may have list of similar file of the same name, the same extension. That is why we have to extract extension from here to make sure that we get the extension, and we also want to make sure the extension is exactly what you want for, and also the name matches the name being found while we're searching from this here. Now, this get file name, the other utility that is here, that actually extract the file name separate from the extension name. This one, this is extension wrap. This one extract the extension from the file name being sent from the client, while this place one here actually gets only the file name. So we want to make sure the file name and the extension are two different things. They compare the file name exactly with the name of the file inside directory, and also the extension. When that is done, we know we have found something, and we'll put it inside the list by appending it, and we appended the entire parts in which the file was found and return that one back to the server here. So by the time we have it down here, so we have a list of file fonts. Now, if the list, if the file exists, if the file is not empty and has a length greater than 0, so we know we have found something. So we will not send the information to this client. Remember that this encode, because this data has to be sent as a binary bytes over the string. So we have to encode this particular string to bytes or binaries, so you can just travel over this network. Now, after that, we want to make sure that we send to the client all the file that exists in the list one by one. It's kind of a loop that will take each particular file from the list and send it to the client. Now, after that is done, then we can print also in the console to the server to show exactly that this is being what we are looking for. So here, by the time we are done here, that is when we are done, we have reached at the bottom of the inner loop down here. We now tell the client that okay, we have finished with your search, okay, and we're waiting to receive again what you want to get from that place. Okay, maybe you want to search again for another file, you are waiting to receive the file name from the same client. Now, if the client now eventually send back, because it's going to come back as a loop, don't forget that this is a while loop and it's truth, that is going to run forever. If we come back here and what to receive from that same client that I say stop, then we done with the search at that point in time, and then we're not gonna come down here finally and close. And that is one thing too. But by the time we get this level here, if we break down here out here, then we are back outside here. We are back outside here. So when we are back outside here, we continue listening for the next coming connection. But let's quickly look at the clients too. This is a client. The client also has to pass through the same similar process like the server. We need to import the sockets module. Now here we found the same thing here as we did in this server. We have to make sure we agree in the address family, that's the IP version 4, and use the TCP connection. Now the host name of the client itself, then the port, they must agree in the same port. We must agree in the same port. It's so important, right? Now we now connect to that port here. Don't forget that the server is continuously listening to that port. When that one is done, and also here, because we are running in the same machine, the host name that is currently the one that the server is running in will be what we get here. But if you are really working in a remote section, then you have to get the remote host server, that's the IP address of the remote system, should be the one that be here, so that it will be easier to connect to that port in that remote. But because we are currently working the two program here in the same machine, so you share the same host name, and that will also make it easy to connect to the server. So when that one is done, it will say the server is being connected. This one is what make the connection happen. So when you now get down here, the file URL of the file here is actually empty. It's an empty string. So here too we have two particular while loop. There's a outer loop and an inner while loop. The outer loop is actually here to make sure that the message you tap down here is not a stop message, it's not exit, it's not end, it's not close, it's not finish. Okay, now if it's end of this one, that means we are trying to stop the connection. So here we will try to not encode the file name, because it is not any of this one that here definitely is a file name that we want to search for, so it has to be encoded here. So we send this encoded file name to the server here by using send all. After that, we now step into the inner loop. While that inner loop is a continuous infinite while loop, so it means that we will continuously receive message down here as long as there are more to come from the server, because the server could just see similar file in different directory and send all those paths to those files here one by one. So we continuously receive them until we found to see the word finish from the server, because at some point down here we can see that it says send finish. When the send finish is received at the client level, then we break from the inner loop. And when we break from the inner loop, we should not also forget that we now continue here. Enter the next file name to search. So we now input the file name, and then the thing continues, except if we tap stop or exit again here to stop it. So here is a point where we want to actually try to download the file, try to get the file downloaded if it actually exists in the machine. Now here file URL, then to see if there's a path actually that exists in the file URL, then we will not do what we now try to ask if the user want to retrieve the file. If it's a yes, then if it's a yes, then we print in the screen the file URL by sending to it the path, and also make sure that the file is here to say this is a network file that can be now be downloaded, because it has to be a network, either a TCP, a FTP, or HTTPS. These are particular URL to signify what kind of communication we are trying to do in the TCP network. Now we'll get the file name, get the extension, then we'll also print the path, we print the name, we print the extension to see. Then here we now retrieve the file. The URL retrieve is another module from the core Python ecosystem. It helps to download a file. We put the URL as a first argument and also put the place where we want the file to be stored or to be stored. I think that is a brief kind of explanation of how the code run and work. I hope it is perfectly clear. I'm going to leave a link to the GitHub where the full source code can be looked at and try to understand how the whole program is structured. Thank you.